to the 11th International Conference on Climate Change, ICCC 2025. We are now in Parallel 2, Session 5. In this session, we will watch your Pechacucha presentation videos. Let's start with the first presentation, titled Resilience in Socio-Ecological Production Landscape, a Community-Based Assessment Approach.
My name is Silvatera Ayu Puspitasari, and this presentation is part of a research with Professor Chen Fau with title Resilience in Socio-Ecological Production Landscape, a Community-Based Assessment Approach. It focuses on the Jatilui landscape in Bali, an example of harmony between people and nature. Human activities and climate change are putting increasing pressure on the Jatilui landscape. These pressures affect not only the ecological balance, but also the social systems that have supported this area for centuries. Using resilience indicators can help guide sustainable landscape management, revitalizing traditional ecological knowledge and integrating local experience over pathway to strengthen the long-term resilience and sustainability of human-nature system. Jatilui is recognized by UNESCO as a sustainable landscape. Tourism provides economic benefits but also risks environmental degradation that affect local communities. Understanding and maintaining the socio-ecological system is important to ensure the sustainability of both people and nature. This study applies a resilience assessment framework developed by the Satoyama Initiative. By integrating social and ecological perspective, it provides evidence-based insight for sustainable landscape management and policy development. We developed the resilience of the socio-ecological production landscape in Jatilui. Indicators were developed and refined through participatory methods, involving community discussion to identify local challenge and response. Data were analyzed using quantitative and qualitative analysis. The assessment revealed that infrastructure adequacy, innovation adoption, and institutional support are the weakest aspects of resilience. These factors act as the main barriers to achieving sustainability in the Jatilui landscape. The study bridges science, policy, and local knowledge. It identifies leverage points for sustainability and offers a practical framework to enhance the resilience of Jatilui's socio-ecological system for future generations. This research advances participatory landscape management approach and supports sustainable development planning. It also established a foundation for future research on community-driven resilience and adaptive management in traditional landscape. Thank you for your attention. If you have any question or would like to discuss this topic further, please feel free to contact me by email.
For the next presentation session, entitled Distribution Analysis of CO2, Gas Concentration at the Putri Tempo Landfill, Indonesia. If you have any questions regarding the previous presentation, please kindly write them in the chat box.
Good morning everyone, I'm Davana Darisdian from Universitas 11 Maret. Our study is titled Distribution Analysis of Carbon Dioxide Gas Concentration at the Putri Jempol landfill, Indonesia. Today, I'll briefly share that we found and why it matters. Landfills release large amount of carbon dioxide from composting waste and vehicle activity. This adds to global warming and poor air quality. That's why we focus on seeing how this issue appears locally. So here's the opportunity we found. We studied the Putri Jempol landfill in Surakarta to map carbon dioxide concentration in different zones and times. This helps create baseline data for emission control and policy making. Next, let's see why this research actually matters. Knowing where and when carbon dioxide builds up is important because it affects air quality, public health, and the environment. By mapping its distribution, we can spot high emission areas and factors that influence them. In fact, supports climate action and healthier waste management. Research took place at the Putri Jempol landfill in Jakarta. We observe 8 points from morning to afternoon on both weekdays and weekends, and measure carbon dioxide along with weather factors like temperature, humidity, and wind speed. The next slide will show the results from this observation. We collected data using a purposive sampling method based on the national standards for ambient air quality. Each point was measured for 10 minutes using a carbon dioxide meter to capture real-time emissions. The results were then processed with spline interpolation to the map carbon dioxide distribution across the landfill. We found that carbon dioxide levels were higher on weekdays and in the afternoon, especially at points 5 and 6, where vehicle activity was intense. Concentration reached above 1,100 ppm, and these variations were influenced by temperature, humidity, and wind condition. The carbon dioxide map clearly shows higher emission on weekdays, with red zone centered in the main activity area of the landfill. On weekends, concentrations drop as operations slow down, confirming that human activity strongly affect carbon dioxide dynamics in the site. This study supports climate change mitigation in the waste sector. We recommend planting carbon-absorbing vegetation, using real-time emission sensors, and improving gas recovery system. This action can help reduce greenhouse gases and promote more sustainable landfill management. In summary, our study highlights how carbon dioxide monitoring at landfills can guide better waste management and climate action. So, thank you for your attention, and if you like to discuss further, you can reach me through the email shown on.
For the next presentation session entitled Production of Biobriquettes from Agricultural Waste as a Renewable Energy Alternative and Climate Change Mitigation Strategy. If you have any questions regarding the previous presentation, please kindly write them in the chat.
Hello everyone, my name is Ali Rahmat. I am from National Research and Innovation Agency, Indonesia. Today, I want to present our research with the title Production of the Biobriquette from Agricultural Waste as a Renewable Energy Alternative and Climate Change Mitigation Strategy. Talking about the climate change is the serious problem. They can make extreme weather and disturbing the ecosystem. Climate change was accelerated by increasing the greenhouse gas from the industry that use the fossil fuel as source of the energy. And we have other alternative like the renewable energy, for example, the biomass. We can use biomass from the agriculture waste like corn cob or coconut shell. And we can convert all of them to be biobriquette. Why biobriquette? Because we can reduce the waste and also increasing the economical value. And of course, this is one of the strategy for the adaptation and mitigation for the climate change that threaten us in the earth. The research was conducted in the National Research and Innovation Agency in Cibinong, Bogor, Indonesia. And we do the experiment by the trial and error to make the best the product. We use the local waste from the Cibinong area. This is the example we carbon biobriquette in the cubic. From the analysis of data, the calorimetric calorie value all is the match with the national standard, moisture content also, but the ash content is beyond the standard. Moreover, we have the volatile matter content is also too high based on the maximum standard. Fixed carbon is too low and the density some of sample is suitable with the standard. For the conclusion, the particle size not really influence the characteristic of biochar in this research, and all of the briquette is not suitable for the Indonesian standard. However, we can still use this briquette for the activity in our household. Thank you for your attention. Thank you for the committee, and I'm very welcome if you want to contact me in alirahmatoffice@gmail.com. See you and welcome to the collaboration in the near future. Bye bye.
For the next presentation session, entitled Modeling CO Dispersion from Motor Vehicle Emission Sources in Makassar City. If you have any questions regarding the previous presentation, please kindly write them in the chat box.
Hello everyone, I'm Nurul Masyarani from Hasanuddin University as a representative of all the authors, and our research focus on modeling carbon monoxide dispersion from motor vehicle emission source in Makassar City in collaboration with BRIN and KIS University. Makassar has seen a rapid increase in vehicle ownership, which has led to higher air pollution levels, especially carbon monoxide that can spread along the roads and affect to the human health. However, there's still very limited research that validates CO dispersion models in Indonesia. This study provides an opportunity to determine how much the carbon monoxide spreads spatially and temporally from motor vehicle on urban roads, and also aims to validate the air dispersion model by comparing it with direct field measurement on different road types. Carbon monoxide is a dangerous gas, and by understanding how much the CO spread in the city, we can estimate the concentration even in the place without monitoring station and help design better transportation policies to reduce emission and control air quality in the cities. To address this issue, we conduct ground measurement to obtain vehicle volume and CO concentration, then calculate emission load using Tier 2 method to input the data using air mode application. And finally, we could validate between CO concentration between ground measurement and dispersion model. Field data. Well, we conduct field data collection at 30 locations, then emission values, meteorological data, and topographical characteristics were processed and spatially dispersed using the AirMod application. And finally, we compare the model result with the field data using a pair sample t-test to check how closely the model reflects real conditions in the cities. The 6-lane two-way and divided road type shows the highest emission levels, which correlated strongly with the higher traffic volume observed along major urban corridors. For dispersion pattern of carbon monoxide indicates that the pollutant spread follows the prevailing wind direction. A comparative analysis between the measured and modeled carbon monoxide CO concentration revealed consistent trend across all the road types. Statistically, validation through a pair sample t-test, p-value 0.45 indicating no significant differences between the measured and simulated data. The findings of the study provide a valuable scientific and policy foundation for developing motor vehicle emission control strategy in rapidly urbanizing cities such as Makassar. Furthermore, this work forms part of the ongoing research roadmap of our Transportation and Air Quality Research Group, which aims to advance towards the vision of zero emission and clean air city. So thank you so much and looking forward for the collaboration. And the last but not the least,
Thank you very much for your active participation in this session of the International Conference on Climate Change. We truly appreciate your time and valuable insights. Let us continue to work together for a better climate and a better world. See you at the next ICCC and have a great day.